I think I mentioned that a lot of statistical theory was developed in the context of agriculture. So let's suppose that we've got five varieties of corn and we just want to figure out which one is best. And so we could call those A, B, C, D, and E. And we're going to test them. And so then let's say we identify five fields where we can grow them. And so here's a field, and here's another field, here's another, and here's another, and here's another. And if you just approach this in a sort of simple-minded way, you might say, let's grow A here, and B here, and C here, and D here, and E here. And question is, should you do that? And the answer is no, definitely not. This is very bad. And you just have to think about it for a moment to see why. Let's say you grow A here, and B here, and C here, and D here, and E here. And let's say that E is wildly successful. Let's say it's much better than all the others. Well, there's a problem, because is it because E was actually better? Or is it because the field where you planted E was a better field? In other words, there's no way to disentangle the seed varieties A, B, C, D, E from the five fields, 1, 2, 3, 4, 5, the five boxes. There's no way to know which of those is producing the effect. So then a better way, maybe you decide to do this. Here's your five fields. And a clever thing you could do would be to split them all up into five regions. And you could grow A here, B here, C here, D here, E here, and likewise A, B, C, D, E, A, B, C, D, E, A, B, C, D, E, and A, B, C, D, E. Okay, that's better. Because if the fields themselves do have different properties, you'll, to a certain extent, disentangle those properties. But it's systematic, isn't it? The way I assigned A, B, C, D, E to the five parts of the five fields. A always came first, E always came last. A always came first, E always came last. And the very fact that it's systematic, again, creates an opportunity for something other than the variable you're interested in to produce an effect that you'll notice. So let's say A is more successful than all the others. Is it because A was actually a better seed variety, or is it because somehow the top of each field was a more advantageous position? And if you do this experiment, if you do the experiment in this way, you have no way to disentangle those two causes. For instance, this could be the top of a hill, and so whoever gets planted, whichever variety gets planted in the first region of each of the five fields, maybe gets more sun all day long, or the right amount of rain. Okay, so the last way, which is the best way and the standard statistical way, is like this. You take your five fields and your five varieties. You take the five fields and divide them up into five pieces each. All right, 1, 2, 3, 4, 5, 1, 2. And then, instead of assigning the five varieties in a systematic way to the five regions, you have to assign them in a random way. And this is called randomization. This is called blocking, the fact that we took the five fields and divided them into blocks and assigned the blocks to the different varieties of seed. And this is called randomization, where we put these five varieties in an entirely random order for each field. And I'm just writing these in a so-called random order as it comes out the top of my head, but you would actually have to do this with some randomizing device like dice or cards or something. Because people are notoriously bad at coming up with random patterns. Well, random selections. The random selections that people come up with always turn out to be patterns. So I'm sure that's happening now. But anyway, this is the best and the standard way to do an experiment like this. You want to test the 5 varieties of seed, and you have 5 fields to do it in. And so you divide the 5 fields each into 5 blocks, and you assign the different seed varieties at random to the 5 blocks of the 5 fields.